find the thing you feel kind of guilty about getting paid for, do the hell out of it, right? Like if you feel kind of guilty that you're getting paid to do something, it probably means you're really good at it and it's fun for you. And if people are willing to pay for it, just go do the heck out of that.
Hi, everyone. Welcome to Behind the Tech. I'm your host, Kevin Scott, Chief Technology Officer for Microsoft. In this podcast, we're going to get behind the tech. We'll talk with some of the people who have made our modern tech world possible and understand what motivated them to create what they did. So join me to maybe learn a little bit about the history of computing and get a few behind-the-scenes insights into what's happening today. Stick around.
Hello and welcome to Behind the Tech. I'm Christina Warren, Senior Developer Advocate at GitHub.
And I'm Kevin Scott.
And today we have Sam Schillaci with us. And he's somebody who was a huge part of the creation of Google Docs. And now he's working with you at Microsoft, right, Kevin?
Yeah, Sam and I have known each other for a very long time. So Google, many years ago, bought the startup that Sam and his co-founders started that created the first interactive web word processor, like back at a point in time where people thought that doing that was impossible.
Yeah.
And that work became Google Docs, and Sam ran all of the Google Apps business at Google for a while. He went on and ran engineering and operations at Box, another startup, until it went public, and was back at Google, and now he works here for us at Microsoft.
That's awesome. And we're really lucky to have him, especially like all of his experience. And also like, thank you for bringing the word processor to the web browser. That's amazing. All right. So let's go ahead and let's dive into your conversation with Sam.
Sam Schillaci works at Microsoft in the Office of CTO as Deputy CTO and Corporate Vice President, focusing on consumer product culture and next-generation productivity. Prior to Microsoft, Sam spent 3 tours at Google, GDocs, Google Ventures, and then Maps and Search. Sam originally worked at Google as a founder of the Rightly acquisition and led the teams that built Google Docs. He has a long history in consumer software as the focus area lead for consumer apps at Google and in multiple startups he's founded. He also worked at Box as head of engineering for 4 years, where he and I met on the technical advisory board. He holds a BS and MS in theoretical mathematics from the University of Michigan, where he focused on combinatorics and discrete mathematics. Sam, it's great to have you on the show today.
It's nice to be here. Looking forward to it.
Yeah, so we always start these podcast conversations by going all the way back to people's childhoods. And I'm just super interested in how you first got interested in science and math and programming, and like just what lit the spark.
Yeah, it's kind of funny. Like I'm a little bit of a black sheep in my family. Like my mom's an artist and my dad's a psychologist and a psych professor. And so like it has always been a little bit of a mystery. Like I've always been a science kid. Like that was always the thing I've liked as long as I can remember. I still have this old microscope my mother bought me or my parents bought me as a birthday present when I think I was like 8. You know, it was like the coolest thing ever that I had this like cool old microscope. And like I was super into it, like always. And like I wanted to be a doctor when I was younger. I did a lot of like biology and stuff like that in high school and things like that. But like when I was about 12, for reasons that I don't even really think I understood even at the time, and certainly don't remember, I really got into doing computing. And the computer at the time was the TRS-80, Model 1, the Trash 80. Convinced my dad to buy me one, this used one from somebody. It was like $600, I remember, which, was like the equivalent of like $3,000 or something a day, like a huge amount of money. I don't know why he did it really, but he did. And he bought it. And like, I remember it being down in our basement, and I would like, write BASIC on it, out of the back of Dr. Dobbs. And the pixels were 3x2. They weren't even square pixels, like this chunky little thing that you could do like really basic stuff on. And if you felt like, not retyping your program, you'd tape it out to a cassette tape and, read it back in later and all that crazy stuff. And then a friend of mine had an Apple II that we played on and, wrote video games. I like pixels a lot. Like I like making pixels on the screen. So that kind of drove a lot of it.
Did your high school have computers? I mean, like this is in the 80s, right?
Yeah, I graduated from high school in 84. My high school didn't really have computers or really have a computer program. I didn't really think of computers as anything other than a fun hobby, even most of the way through college. Like at college, the first exposure I really got to anything significant other than those early things was like the nursing school across the road from my dorm had a basement full of Mac classics that you could go use. And I would go write my papers on them because they were awesome. Like I didn't have to I was a terrible typist and I never learned to type touch. So, or, to actually type the right way. And so that was great because I didn't have to white out and backspace and retype all my papers. I would just go do them there. And I even remember even then, all of my friends and roommates and stuff, classmates thought it was a weird thing to do. Like, why would you go type on a computer? Like we've got all these perfectly good typewriters. And I was like, no, this is way better. And that's where I sort of started getting into them. And then I did a lot of goofy, weird little side programming projects in college, making sort of pseudo 2.5D landscapes that were randomly generated that I like to look at and crazy stuff like that. And then, I took one CS class in college. It was the Knuth algorithms class, first book. It was cool, but at the time I was really into math and really into science and thought I was pre-med, and I was doing graduate math classes. So that intro to algorithms class was just super easy. It was the only thing I ever got an A plus in ever in college. And my math profs really looked down on it and sort of discouraged me from doing computers because it's there's math, then there's applied math, and then there's engineering, and then there's whatever the hell those hairy computer guys are, it's the bottom of the bucket. So I didn't really pursue it. I didn't get a CS degree. Kept doing my math degree. Got to the end of college, and my college roommate, who was one of the co-founders of Writely, ultimately had dropped out to go do a company that was also a word processing company, a thing called Ann Arbor Softworks, that got bought by this company called Ashton Tate before Oracle killed them, and he got moved out to the Valley, and I didn't know what to do with this weird math degree. And I didn't want to be a doctor anymore. And so I just moved out to the Valley and started writing code with him. We wrote a video game and then ultimately wound up starting 6 companies together and just worked together for about 25 years.
That is...
fell into it. I mean, just absolutely fell into it.
Well, so but going back a little bit, I'm curious, why math?
I don't know. I liked math. I thought it was fun. I've always been kind of an abstract thinker. I like math. I like I like being able to kind of tinker and build stuff with your mind. I mean, that might be the kind of the through line of all of this. Software was always, you and I are both makers. We like to make stuff. And I always liked software because it was the most that you could, the most direct connection between your mind and making something, right? As little mediating that as possible. Math is kind of the same way, right? Where you can think really interesting, crazy, cool thoughts, but you can do this this interesting structured way where you're not just bullshitting. You're actually I did a bunch of stuff with set theory and the completeness and correctness theorem and the omega number and all this other the halting probability. It's just wild stuff. It's metaphysical and cosmological, but it's grounded in some real rigor, which is just a really interesting way to think about the world. Right? I just find it to be this amazing tool set for understanding stuff.
Yeah, it is. It is an interesting. It's an interesting thing. It's. I mean, some mathematicians go off in a completely different direction, but a lot of what you do in math, and I don't think I really appreciated this enough when I was taking a lot of math in college, is that it is teaching you, in a sense, how to do abstraction really well,
how to decompose problems, and I think there's very little that's sort of really directly valuable in the computer career from my math degree, although there are definitely some ways of kind of thinking about Venn problems and stuff. But the thing that's super useful about it is it taught me to be alone in a room with an unsolved, seemingly unsolvable or extremely difficult problem, and just, not have any excuses, just work through it. Right. Yeah. And one of the, I had this class at one point, there's group theory, which most people know is sort of this abstract theory of algebra. And then there's semi-group theory. And semi-group theory, you start to take away some of the axioms, you don't have associativity or commutativity of the binary operator. And man, is that stuff hard. You look at these things, these theorems that you have to prove, and you're just well, that's obviously true. And there's but you got to prove it. And there's just no place, it's a seamless wall. There's no place to get any traction on it at all. And sitting in the room with those things and spending 8-10 hours on a 2-line proof, is just a really good mental discipline of there's a solution. You just got to dig away at it, and you got to break it down to smaller problems, and you got to, figure out what is true and what you hope is true and how you get to the things you hope, all of that skill is super valuable, I think, in engineering.
Yeah, I learned a similar set of lessons when I took linear algebra in college. So my linear algebra prof, it was a very theoretical course, and 100% of your grade were two exams, a midterm and a final. And on the two exams, they were 10 true and false questions, and they were take-home exams, and you could spend as much time as you wanted doing them. And it was brutal.
Yeah.
Like you would take those home, and to get to, I'm confident that this is true or this is false, was a massive amount of theorem proving.
Yeah. I remember doing one of these midterms like this, I think for like one of my group theory classes, where it was 12 problems like that. And I took it home over spring break and I got one problem done a day.
Yeah.
You know, like it literally like could grind through one of them every morning, and then I would go out on the beach or whatever where we were. Yeah, I think that discipline is, this is the nice thing about math, I think, is that it's very easy to fool yourself. You look at something and think you understand it, or you look at something and you think you know how to do it, but like doing it is the proof, right? And math really teaches you that. Like,
I also had when I took combinatorics in grad school, I had a professor who would occasionally slip an unsolved problem into an exam. And what that teaches you is what to do when you are faced with a problem that is literally too hard for you or anyone else to go solve. Can you get anything out of it? Just the process of making the attempt. And the answer to that question is like, obviously, yes.
I had one of those happen by mistake once in one of my advanced classes where the prof would give 1, 2, or 3 stars. 1 was like, you really should be able to solve this. 2 was like advanced. 3 was unsolved. And he accidentally mislabeled a 3-star as a 1-star. And he had a very unhappy group of kids on Monday morning who had spent the weekend banging their heads against this obvious problem that was unsolved, actually.
So how did you go from being a theoretical mathematician to, I understand the impulse to go work on some of this software, but like why work on software in context of starting a bunch of companies?
It was a little bit of this like kind of falling into it and a little bit of networking, right? Which is also one of the reasons why I try hard to like network outside of my particular group, because I think networking is why we don't have good diversity in the tech industry. People network with people like them. And so you kind of have to force yourself to go, break those networks. And I think it's an important part of increasing diversity. But we were at Ashton Tate. Ashton Tate was, we got hired into the Mac division of Ashton Tate, and they were in the process of being strangled to death by Oracle, basically. So they were a database company that Oracle was crushing. So that job only lasted about a year and a half. And about 6 months into it, it became very apparent that it wasn't going anywhere. And we were trying to figure out what to do next. So my friend and I, Steve Newman, were just bored. And we wanted, they'd loaned us like a Silicon Graphics machine, and we were playing around with the flight simulator on it. And so we were like bored dudes, and we wanted to play games, and there weren't any really good games. Like Castle Wolfenstein was the game that was there at the time. And we just wanted a Twitch game. And so this is actually a pretty good set of learnings from this game. We built this thing called Spectre, and it was a very early multiplayer game. It wasn't even Ethernet. It was over AppleTalk. So you could play against other people in real time, in your LAN, within the office. Just a straight up first-person shooter. You're driving around in a tank. It looks like this old game, Battlezone. And it taught me a whole bunch of stuff. It taught me about really focusing on user need and user value. We knew what we wanted. We were the customer. We were iterating with ourselves. We wanted a Twitch game. We wanted it to feel really clean. We wanted it to be really straightforward. We wanted stuff to blow up a bunch. And so we built that, which was really hard to do on the hardware of the time. It was super hard to do with the networking stuff we had to deal with. So I learned a whole lot about value in programming is in confronting these really annoying hard problems and getting them right, because we got a patent for how the rendering worked because the hardware was too slow to draw all the pixels, and so we had to erase a bunch of them, and there's all this kind of stuff like that. So that taught me a whole bunch of stuff, and that wound up paying for 4 years of my life. That we sold it to this company, or licensed it to this company that just published it for us, and that was good money for me, as a kid, kind of to live on. And then, as Ashton Tate fell apart, the group that had been part of that company went on to do another startup, which didn't really go anywhere. But Steve and I went with them and worked on that for that 4-year period. And when that failed, we sort of took the pieces of that, and the .com boom was starting, and so we turned the pieces of that company, which was like a personal information manager, but we had built like a good cross-platform Mac and Windows app framework out of it. We took that and quickly pivoted into building internet tools, one of which we sold to Claris. So that right there is like 3 startups in a row. It's like bing, bing, bing. Kind of by accident, but again, like in that era, I spent a lot of time like feeling bad that I was doing something fun for a living. Like I kept feeling guilty that I sort of dropped out of being pre-med to go do this thing. And I literally spent like the first 10 years I was in Silicon Valley thinking that computers were a fad. I needed to go back to med school, get a real job. Like this is just kind of a goofy, stupid thing to do. And eventually after about 10 years and several successes, I was like, well, I guess this is my life now. I've got money in the bank and this is kind of fun and it seems to be continuing to develop. So I guess this is a career. Let's go do this. And there's actually a lesson in there that I tell people all the time, which is, I think we're really confused mostly. We have this kind of Calvinist idea in our heads that like work is equivalent to suffering. Like you're not really working if you don't hate it. And I don't think that's true. I actually think the place for people to be, this is the career advice I always give people, is like, find the thing you feel kind of guilty about getting paid for and do the hell out of it. Right? Like if you feel kind of guilty that you're getting paid to do something, it probably means you're really good at it and it's fun for you. And if people are willing to pay you for it, just go do the heck out of that. Like career growth usually comes from having impact, which usually comes from doing something you love with a lot of passion. Like it's not that much more complicated than that. So that's how, I never started off with like, I'm going to go do a bunch of startups. I just was like, what's the next interesting thing I want to go work on? Let's just go do that with all this energy. I always liked working with my friend. So we just kept doing stuff and we kept making money and it kept being successful enough. So like, why stop?
Yeah, and I think you had another couple of pieces of interesting career advice in there as well. So I totally agree with what you just said. I also agree that working with your friends, like whether they were your friends before you start something or whether you like form bonds with folks, when you join a company and you start working with them, I think that's pretty important because on most days, like even when you've got a thing that you're passionate about and you nominally enjoy, like there's just a bunch of hard stuff you got to go do to make anything worthwhile. Right. And so you do want to be doing it with people whose company you enjoy and where you feel like some degree of camaraderie with them. Right. Otherwise, it's just, you and I do this now, right? Like I don't want to sell the image that Microsoft is, somehow perfect. Like we got hard things we work on all the time. And then the two of us, like, because we're friends, we will, we will complain to one another. Right. And, the thing that you try to do, I try to do, I even do this in my marriage, is like you want to sort of be grumpy out of phase with each other.
Yeah, that's right. Yeah, you want to be complementary. There's all kinds of complementarity that you want in these partnerships, right? That's definitely one of them. Skill sets is another one, right? Like you want a linear thinker and a nonlinear thinker, and then you want them to be like, in creative tension with each other, basically in a constructive way, right? Like,
the other, like the most interesting, like complementarity advice that I ever got is I had a mentor years ago who told me to imagine a histogram that has 5 buckets, and on the extreme left end of the histogram, the bucket is labeled idiot, and on the far right end of the histogram, the bucket is labeled genius, and in the middle is average. And you can take everything that you do and every skill that you possess and put it into one of those buckets. So like that's not the breakthrough thing for me. Like the breakthrough thing was this mentor said, if you work really, 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 really hard, you can move something over 1 or 2 positions on that histogram, which means that if you've got a thing that you are an idiot at, like
you might get the average if you're lucky.
Yeah, and every minute that you spend trying to get to average is a minute that you're not spending doing the thing that you're a genius at.
Right.
And like what you want to do with teams or partnerships or anything else, to your point about, nonlinear versus linear thinkers, is you want to you're trying to do something together. You need a set of skills to go do the thing. So how do you figure out this thing where everybody's histogram adds up to above average, where you can have everybody focus on what they're really good at?
Well, and the real challenge with this is that, just to keep going with that example, sometimes the if you got two geniuses that are pulling in different directions, they neutralize. And then you don't have either genius. And so in fact, that often happens, right? I had this tension a lot with my co-founder, with Steve. When you have genuinely different perspectives on the world and you are genuinely both good at them, those are often, you're kind of blind to the other perspective to some degree.
Yeah.
And so finding a way to understand and respect the other perspective, even if you don't really get it, you just understand this person, I don't get their domain. I don't even maybe necessarily fully value it, but I understand that it is valuable and they're good at it. And so I'm deliberately carve out some space. I always tell founding teams, pick somebody you like arguing with.
Yeah.
That's, don't pick somebody you like. It's easy. Don't just go found something with a friend. Pick somebody that you enjoy arguing with, where you have genuinely different perspectives, where you're struggling to even find common vocabulary, but it's okay. You're willing to have those arguments, kind of find that common ground in between your domains. Because often there's super small overlap in the Venn diagram of even the language of these, right?
Even going back to marriage, my wife is smarter than I am, and a lot. And there were a bunch of things when we first got together that both of us were good at and both of us liked doing. And eventually we learned that we just sort of had to pick on a bunch of these things, where I sort of had to say all right, this is going to be your thing. And I'm not going to try to get up in your business on this, and vice versa.
Everybody has comparative advantage and stuff too. For one of the things that drove me nuts in my marriage for a long time is I have opinions about stuff and my wife doesn't as much, right? I'll know what I want for dinner and she won't, or whatever. And you just sort of decide okay, well, that's fine. You kind of get comfortable with those different modes and you take that role or whatever.
But I think the thing, that we're sort of getting at, the meta point, is you just really have to be thoughtful about how you're trying to do things together with other people.
Right.
You have to pay attention to what the dynamics are and try to make things work for everyone.
Well, and you have to recognize that that's not if you're struggling with a coworker or team member or whatever, that's not an anomaly to be worked out. That is a fundamental requirement of high functioning teams, is that you're going to have tension between different perspectives. And that's a fundamental critical value of being a mature team member and leader, is that you're actively aware of this and managing it. There's no easy, if you snap a bunch of people together, they're all the same person, that team will fail.
Yeah.
Right? There's always tension in these teams that has to be to have them be high functioning. That is a skill.
And I think the thing for managers as well is realizing that you can realize all of what we just said and still be a victim to some of the stuff yourself. And which is why it's really important, if you are leading things, to have people in your network who can help you go deal through your own short-sightedness, where intellectually you should understand how to go deal with it, and yet you just aren't, because you're a human being.
That's actually a really good illustration of one of my favorite things in tech in general, this favorite patterns that shows up in a bunch of different ways, which is this tension between long-term and short-term, right? The manifest is the tension between what I know I should do in the long term versus what I want to do right now. I always joke, it's well, I want to be on a diet, but there's a donut in front of me and I'm eating that thing, that's kind of the easy way to think about it. But here, right, what you should do. You should build and manage this thing in the long term, but it's hard to do, because what you want is a day-to-day life where you don't have to deal with tension among your team members. And so you're kind of biased in this direction of picking the easy thing. And the thing you mentioned of reaching out to outside groups and stuff like that is a common solution to that. You have an externality. You pick something that's an external forcing function that makes the short term kind of equivalently expensive in some way to the long term, or reduces the cost of the long term. So you do the right long term thing. But that pattern manifests in architecture, it manifests in development tooling. I mean, it manifests everywhere in the tech industry. I see it, as one of the fundamental challenges of doing what we do very well at scale.
Yeah, so going back to what we were talking about 10 minutes ago, just in terms of career advice, like one of the other nuggets that you had in there that is worth calling out is it is very important, I think, to choose to go work on things that are hard. Like usually the meaningful things that have impact, like things that have lasting value, were hard. And like if they weren't hard, somebody else would have done them, and the problem would be solved. But like we have this hypothetical frontier that we're all as human beings trying to collectively push forward, and like getting the frontier pushed forward is just a inherently hard thing. It pushes back against you. And so the only way you make progress is just with the choices that you make. You have to choose to go work on hard things.
You have to sit in discomfort all the time with this stuff.
Yeah.
Which is hard for engineers, right? Like the engineering mentality, we like neat, people like things to work. Our job is to solve problems. And so we don't like things to be unsolvable or to confront stuff where you don't know the solution or whatever. Like, one of the common mistakes people make is waiting for that moment where the thing seems obvious and easy to do, because it's, as you said, it's too late. Like, I always think the right time to work on a new problem is when you have this pit in your stomach where you just know that it's going to happen, but it also like, you just know it's going to be hard and miserable to grind through it because it's so early. And like, we can talk about this in the context of GDocs. Like I always give this example in the early days of Rightly, where like, I had this, I can't claim I had the full idea for GDocs early on. What I mostly had was just me messing around with JavaScript and content editable in the browser because it seemed like a fun thing to play with, which is a lot of what we would do. But, we had this idea of doing this word processor, and we kind of stood it on its feet, and we cleaned up some of the early collaboration stuff. So we kind of worked together without stepping on each other. And, we had this sense, first of all, we had this sense that like this was cool and it was going to be really hard to pull off. And you kind of had that sinking feeling in your pit of your stomach, like, oh man, is this going to hurt? But also like my two founders said, this is a dumb idea. We're not going to be able to build a word processor in the browser that's satisfying. And the funny thing is that they were right as well as being wrong. Like in the moment, they were right. The browser of the day, IE4 and early Firefox and all that stuff, like, there's no way, man. Like, they were really not ready. The JavaScript environments weren't ready. The DOMs were flaky. There were no standards. Like in a zillion ways, we were not ready. But the interesting thing was like, if we solved enough of the problem, we confronted that hard stuff at that early stage and solved enough of it to demonstrate value to ourselves and to some other people. And that started a flywheel, right? And that flywheel would between like the browser got better, the app got better, the users adopted it more, the browser got better. Like we had these three pieces of this triangle started to spin. And that dragged us forward to where we are now, where the browsers are super capable, the apps are super capable, billions of people use these things. So like, that's the, that 100% agree with you. Like that is the thing you have to do is like, you have to be able to see those vistas as they open up, and then you have to jump into them when they're nasty, hard to deal with.
Yeah, and I look, I think it's a good thing to just sort of pause and think about. So in 2022, as we have this conversation, people take for granted that, like, obviously you're going to be able to have a interactive word processor, with collaboration, and you can comment and you can share it with anybody in the world, and like you've got all of this stuff. When were you first doing this? It was 2002? 2005. So like in 2005, like nothing like it existed. No. And so everything today that's in your life, whether it's a PC or a laptop that you're able to buy for not that much money, relatively speaking, that you've got an internet that's got all of this information on it. You got a device in your pocket that connects you to all of that. You have things like everything that we take for granted now was impossible at some point in the not too distant past.
Right. The iPhone didn't exist when we started doing this. Like we were right before it, right? Like, I don't know if AWS was a thing then, but I don't think it really was. Like, I think like LoudCloud was a thing back then, right? Like it was sort of like, like all of it had to happen somewhere, right? Like, and I think Jobs had a quote about this, right? Like he realized at some point, like all the cool stuff in the world, like somebody came up with it, and that somebody could just be him. And, so that's why he came up with a bunch of stuff. Like he's Jobs, but like, he's right. Like everything, gets done by someone somewhere. So, if you don't confront these seemingly almost impossible things, then you don't get to be one of those people. Like, it's just kind of the price of admission is you have to deal with it.
Yeah.
I mean, the other lesson I take from that is, and I tell people this all the time, like I'm not that smart. Like, I didn't, foresee the cloud or anything like that. Like, we were messing around with stuff, and we were listening to signal from the market and from users, right? And that's really the important thing is, this stuff in retrospect, 16 years later, looks super obvious. Like, oh yeah, of course, collaborative documents and mobile and all this other stuff is obvious, but like, it wasn't at the time. It was super controversial. And there are a bunch of reasons why stuff like that is controversial. It's not only that it's just hard to implement, but there are also like kind of natural psychological reasons that people push back on stuff, right? Like, you also have to remember, like, in that era, we were mostly on the desktop. The internet was just kind of starting. And, the idea was like, well, Microsoft has won this game. Like, Office is this giant thing with all these features, and they have this distribution channel, and software comes in boxes, and that's just how it is. And so, like, this disruption of, like, we're going to distribute differently, we're going to focus on convenience instead of functionality, we're going to kind of go down this different path. Like, it was super controversial, challenging to a lot of people's worldview. And when your worldview is challenged, you have this very stark binary choice that you have to make, which is I'm wrong or it's wrong. Like, that's, something, either I was wrong about the world, or like the world is right, and this thing is wrong. And so usually people choose the thing, and humans are great at coming up with stories for whatever they want, right? Like, we all know this. So, like, if you want to think a thing is wrong, a new challenging thing that challenges your worldview, if you want to think something's wrong, 100% you will find a reason why that thing is wrong. Like, I told you that, like, my founder said, like, the browser won't support it. That's a good example of that kind of story. But almost every new technology gets dismissed as a toy or impractical, or there's no use for it or whatever. And I always feel like the right place to put yourself is the what if, not the why not. Right? Like, yes, you have to ask the question of what if. Like, when you confront this thing and you see a bunch of problems with it, the why not is like, well, here's all the why not. Here's why it's not going to work, right? Here's all the problems I can see, the stories I can tell. But the real thing to say is, like, well, what if it works? What if, like, we transform software into being this zero install on demand global thing where we can collaborate with people? What does that world look like? And if that world's compelling, then it's worth doing the effort to break through all the problems. And that's the much better mentality. But you have to recognize that in the moment, you won't see the vision. Like, you won't see the prize. Even if you ask the what if questions, you'll maybe see some of it, but, like, you just kind of have to, like, grind through these things, like, make them happen.
Yeah. It's sort of interesting. I mean, Bezos has said this a bunch of different times, and I suspect you and I have both experienced it over and over and over again, of other people telling you why it is the thing that you it isn't going to work. I mean, one of my favorite examples, and I won't name names, is when I first joined LinkedIn, right before LinkedIn IPO'd. We had a whole bunch of work that we had to go do to make all of the company's development infrastructure better. Like, we had just gotten ourselves into a state where it was getting progressively harder to do the sorts of rapid software development that a consumer internet company needed to be able to do. And I came in, and there were a bunch of people inside of the company who knew what needed to be done before I got there. Right. But there were also, like, a bunch of people who looked at what they were suggesting that we do, and they would be like, oh, this is impossible. Like, we'll never be able to pull it off. These 3 people who tried to do this before failed, and it was a miserable, embarrassing failure.
That's my least favorite excuse.
Oh God, it's the worst.
I'm just like, just because you can do it doesn't mean I can't do it, right? Like,
yeah, and so the interesting thing, we did a whole bunch of things that I think are innovative, and, like, some of them are now multi-$10 billion public companies that spun out of even what LinkedIn was doing. But, like, the core of what we were doing, like, wasn't rocket science. Like, I had sort of done it a couple of other times in different contexts, and it was just a matter of will and determination and like enough patience to get it all the way over the finish line.
Yep.
And I remember going into a meeting with a bunch of people and told them what the plan is. And the plan was uncomfortable because it meant, you had to, like, we literally we went over this bridge from old build and deployment infrastructure to new and burned the bridge behind us. We literally tore the old system down, where there was this 3 or 4 week period in December of 2011, right after we'd gone public, where we did not have the capability to deploy new software.
Yeah, that's pretty terrifying.
Yeah, and so like, I was telling people, what this plan was, and like why it was important to go do it and what we would get on the other side. And I had, like a senior person look at me and it's like, well, you better hope you're right. Like it was this personal thing that I was doing. I was like, no, I'm not doing this for me. I'm doing this for all of us. Like we all need to hope that this is right.
Yeah, the proper response is you better too, right? Like,
yeah,
we all better hope we're right. No, sure.
but yeah, it is my least favorite thing is like somebody telling you that a thing is impossible.
I mean, one of the lessons, the real lesson for me from the early days of Riley, which was super valuable, was this exact lesson of like, don't listen to the naysayers very much, right? Like, and you get this, like, particularly really disruptive things. When you have a product idea and you give it to people, mostly what you get is like a bell curve of interest, right? Like some people are kind of interested. They're sort of, smeared along. It's not like there's not really high emotional valence anywhere. The really interesting stuff I found has high emotional valence. You either get a small number of people who are totally on your side because they see the vision, and the rest of them want you to stop doing what you're doing immediately or have it die in a fire or whatever. Like they're violently opposed, and there's very little in the middle. And we had that with Riley for like a year. Like after Google bought us, we were at Google. I had executives at Google tell me it was a bad idea and they didn't want to fund it and that we should stop doing it. And I was like, I've got millions of people already that think it's a great thing and the company's moving over to it. And like, what are you talking? So like, fortunately, like we had enough, like I was not, I hadn't learned the lesson, but I had, a contract that I had to fulfill, and I had backing of Eric Schmidt, and we had like a bunch of reasons why, we kind of believed in it and kept going, and I didn't listen to the naysayers. But like, that was a real privilege of like being given permission to not listen to the naysayers and then realizing after the fact, like, holy crap, like I'm really glad I didn't listen to them because that would have killed this thing. And it was critical to it coming into existence that I didn't listen to the naysayers. And that like, that's a really deep lesson for me of like, I am very comfortable being in, conflict or, in these kind of early chaotic things, like taking these controversial positions. If I have conviction, if I can see a path and I think the problems are solvable and I have a vision for where I think we might be going, like, it's fine if people object. Like, it's kind of a good, it actually is a good signal. Like, you want it, like you want controversy, you want that energy.
Yeah. And what's the worst that can happen if you fail?
Right. Well, even failing, like, the worst thing that can happen if you fail is you don't learn anything. Yeah. Failing when you learn something.
Or that you learn not to try again.
You learn not to try again. Yeah. Like, I've there's all kinds of things where I've seen teams try stuff and they'll say like, well, that didn't work. And, we can't do it again. I'm like, no, actually you achieved part of it. You just didn't get it quite right. Right. You didn't quite get you didn't quite understand the market. You didn't quite understand the problem. But you made progress. Like you got energy out of the system. Like keep doing it. Like, you'll get there.
Yeah. So. I was having this conversation with someone yesterday who was, who had just joined the advisory board for an energy company. And the particular energy company is doing something that's completely preposterous sounding. But it is a thing that if it's successful, like we would all want it to exist. Right. It would like everybody would want it. And so, the only question is like, is it a good use of time to go push this thing forward that everybody will want if someone can make it exist? And like, this person I was chatting with is like, yeah, it's like, I don't know for sure whether this is going to work, but I know they're going to make at least a little progress on it. And, even if the person who solves it later, like they're going to refer back to this and sort of say like, hey, this was like, an important thing that helped me solve the eventual problem.
Yeah. That's kind of, there's a book that I like by this guy named Steven Johnson. It's called Where Good Ideas Come From, I think is the title of it. And he talks about like the adjacent possible, right? And in this principle that like, it's very difficult to see more than like one step past the edge of what's known and possible currently. Like not many people can see really 2 or 3 steps into the unknown. We kind of make these, you know, small, we move kind of in small incremental steps. And like sometimes you get like kind of concurrent inventions of things when, you know, a bunch of different fields advance to within, you know, each of them is one step away from coming together on some new thing, like microwaves, I think was the example he gave of like, there are 3 or 4 inventions that like, you know, all of a sudden, if you were in like one of 3 positions, you were one step away from putting these pieces together. So I think like you know, it's important to make those like those steps forward. And, you know, it's fine to not really quite know the solution to the problem as long as you can have these kind of relatively short chains of problems that you think you can solve, or at least you know the vector that you need to solve them along, right? Because you'll get there eventually. Someone will get there eventually, even if all you do is move one step. If it was 3 steps were needed, well, then the next person only needs to do 2, right?
Yeah. Another really good book along those lines is Arthur C. Clarke's Profiles of the Future. And like this is the book where he articulated his 3 laws. Like one, everybody knows the 3rd law, which is any sufficiently advanced technology is indistinguishable from magic. But the point that he was making in that book is that it's very hard with high precision for anybody, no matter how smart they are or how good they are as a futurist or a scientist or an engineer, to predict exactly what the future is going to be like in 20 or 30 years. And, you know, he had some practice with this because he was a science fiction writer in addition to being a really quite a good engineer.
Right.
His framework for looking at the future is like, you know, don't try to make very specific predictions about the future. Like make predictions about what the shape of any possible future must be. Like where are the, you know, progress trends going? Like what is going to have to be, you know, like a set of things that will be true in the future. And then, you know, sort of direct your effort, like to your point, along those vectors. You know, you could not have predicted when we were, you know, even when you and I were in college, that we were all going to be carrying a smartphone around in our pockets. Like it's like it may have, I think our smartphones, right, are even like a little bit crazier than the like tricorders from Star Trek.
Well, yeah, and like in that era, I remember the Cray 1 was like the hot computer, and I think that's about as powerful as like an iPhone 4 or something like that. You know, it's like, so, you know, like if you knew Moore's law intimately and you liked math and did the math, like you still don't have a visceral feel for how much that's going to change the world, right? Like,
but you just named the trend. So the trend is like you have these exponential progress curves on the price of compute, the density and the density of compute, the like energy density of batteries, like the transmission and receiving bandwidth of wireless communication. And so like all of these things are sort of inflecting up. And so if you look at all of that, like you may not predict Android or, you know, the iPhone, but, you know, something's going to happen there.
One of my favorite things right now is the learning rate thing, right? Like we understand there's about an 18% generational learning rate with solar panels and about a 6% generational learning rate with batteries. Every time you double the deployment, you get that percentage increase in efficiency. And like, you know, it seems kind of funny, like where'd that come from? But if you look back, like literally like 40 years, you can see it. I was just talking to my wife yesterday about EVs, and we're looking at like buying an EV. And I remember when the Tesla came out, that was like 6 generations of batteries ago. Originally, like the 300-mile range that everybody wants was really hard to achieve. And now all of a sudden, like every EV that's out there has a 300-mile range. And you're like, wow, like did they all get, you know, smarter or whatever? Like, well, no, kind of they did. But like also batteries just got way better because there's a baked in learning rate. And so, you know, and you look at a lot of climate, like alternative energy and climate change, like I still think people don't fully factor this in, that like solar is going to just keep getting better. And, you know, all these wind, I think is 12%. You know, you can see the learning rates in a bunch of these technologies. So,
yeah,
you know, like that trend is durable for a while.
And you get to the point where at a certain level of scale, you just get much broader participation in an
Yeah.
ecosystem than in the beginning. So it was sort of an elite thing, like elite engineering schools and like just a very small handful of companies could have even conceived of building something like the Tesla Roadster when like when Tesla really started getting going. Today, like I was hanging out with someone the other day where like they've got two classic cars they're converting into EVs right now, and like you can buy all the components offline, the motors, the
Yeah.
inverters, the
Makes
power
it easy.
management systems, the like all the components in the car talk over this car area network that's standardized. Like not everything is great, but it's almost like the early days of the PC ecosystem where you can just like
Right.
sort of buy a bunch of stuff, build your own PC.
Right.
Like you can buy
Yeah,
a bunch of stuff, build your own electric car.
Yeah, you can totally see this coming. I also like to talk about one of our favorite subjects too. I think this is going to happen right now with AI. I think this is like I have the same sense, all kind of pull all these threads together. Like I have exactly the same sense of imminent disruption and that kind of uncomfortable pit in your stomach when something is going to happen and you have to do the heavy lifting engineering for it about
Yeah.
AI. And I think we're at the cusp of a fourth transformation, right? So like PC, the internet, and mobile were these three transformations where a lot of activity became suddenly accessible to computer programming,
Yep.
right? Like, and I think that accessibility or legibility, however you want to describe it, is like the core thing, right? Once like an area of human activity becomes accessible to software in some way, you get these explosions of businesses and value. We got all the stuff that the internet gave us, and then the mobile let us take it out into the real world. And like every stage, like the businesses got bigger, the value got bigger, got more ubiquitous. And I think AI is going to take this into the cognitive realm now. All this stuff that's cognitive, like natural language and object recognition and video and just reasoning about the world, is now
Yeah.
becoming very accessible, not to programming in like the large scale, like, oh, we've got these large models to do that stuff, but programming in the sense of like, I can give it to like a guy who's like the guy building or gal who's building the car, and like they can snap pieces together and build interesting things out of it. And that
Yeah.
like accessibility to folks of these cognitive, like I think it's going to be hugely transformative. And I suspect people listening to this, half of them are rejecting that out of hand. Like it's, and here's the why not. Like it's happened before. It's really hard. I don't like that. I don't want people to be out of jobs. Like all those reasons.
It's
like,
too expensive. It's dangerous
like-
in these ways.
But like,
And look,
we'll solve them. Like we'll solve those. And the what if
We
is
will.
amazing.
Yeah, and that is the thing. I wrote an essay in that got published in the March issue of Daedalus, which is the journal of the American Academy of Arts and Sciences, where the framing that I was proposing for thinking about this stuff is just sort of cognitive work and like thinking about AI as a set of tools that we're developing that will help us with our cognitive work. Like the same way, and like we had a whole in the Industrial Revolution, like you had this big set of changes that were happening with physical work. And so the practice arrived a little bit before the theory, but the theory came that you had thermodynamics, like you had very precise definitions of what physical work was. Then you had whole engineering practices that, developed around it. And, it is just ubiquitous in the industrialized world. Like, I think that's the kind of transformation that we're about to go through.
And I think like similarly to that, like there's this process we need to start of like unlearning some stuff, right? Like we had to unlearn what work meant and kind of relearn it for that process. And I think we've spent 40 years convincing ourselves as computer technologists that we have to do a bunch of work for the computers. Like we have to build a schema and we have to put things in a form and we have to like structure data in certain ways. And like it was true, we didn't have the tools for that. Like, but now we do, and now we understand how to deal with messier stuff. And we don't have to have forms. We have classifiers instead, and we have things that have judgment, and we have things that can synthesize.
Well, and there are even some more subtle things. So yeah, I've begun to think about part of. So you as a trained mathematician and like both of us as practicing computer scientists and engineers for, a handful of decades. Yeah, part of our job is like we wield these like big stacks of abstractions to go solve problems. And like part of the reason that we need these stacks of abstractions is like you can only do so much with the brain that you're born with.
Yeah.
And it's almost like the abstractions are a compression algorithm to allow you to like go approach problems and like, just sort of fit all of these tools inside of your head. So I a lot of people I think that mathematics itself is sort of this like universal thing, that it's like a necessity of the universe. And Ted Chiang, who wrote the short story that became the movie Arrival, I think sort of pokes at this in a bunch of different ways. Like, mathematics may be more about humans than it is about the universe. And when you have a tool like AI that's a different way to do a whole bunch of cognitive abstraction, you can sort of get after a bunch of problems that we used to solve with mathematics that you're now going to be able to solve in a different way. And like that will be uncomfortable.
It's really interesting. Like one of the most fascinating things about AI is less that it thinks like us and more that it doesn't.
Correct.
Like that's the interest. Like it thinks as well as we do, but in a different way. That's fascinating, right? Like a lot of that, like the deep dream stuff, that just like blows your mind with some of these weird ways they'll produce images, or just DALL-E things. Like it's just really interesting, like what comes out of these, right?
Yeah, and even even what you said, like we've got to get new vocabulary for talking about it, because like in a sense it doesn't really think at all. Like when you say think, you are thinking about what we're doing right now.
Right.
You have this cognition that's running on your brain, and like it is a different qualitative thing than what a model does.
Well, it's interesting. This is going to get too abstract and too deep for us to dive into, but like to some degree, like our brain is a bunch of these networks, right? That kind of are strung together in a certain way. And what we're doing is making new ones external and also kind of folding them into the mix, right? So it's just defining what to think means is challenging all by itself, right? Like we have this, to your point, a very particular sense of what that combination of networks.
Yeah, and look, there's just a bunch of things that you're not going to be able to get a machine to do. I wrote about this in my book, and it started as a dinner conversation I was having with a bunch of people. Like it's one of those weird dinners. Like it was Yuval Noah Harari, who wrote *Sapiens*, was there, and like a bunch of other people, and we were we were talking about some of this stuff, and I made this assertion that I believed at the time that this group of people made me rethink, which is like, I don't think that a machine will ever be able to compose and perform music in a way that gives me the same emotional response that like Murray Pariah gives me when he is performing Chopin's G minor ballad. And they were like, yeah, why do you believe? And like they just sort of push back hard on the assertion, and like they probably were right. Like you could build a system, I'm guessing, that would produce music in a feedback loop. Like you could sort of put a bunch of EKG probes on you, and like you could probably have the system in a closed feedback loop give you the same like autonomic response, like the
right.
shivers up your spine or goosebumps. But like that to me still is qualitatively different than like what I get when I listen to this performance, because it's like this human composer from a different time who is like trying to communicate something to everyone else, and then this performer from another different generation and a set of experiences who takes this work and interprets it in a way that no other performer interprets it, that produces this emotional response in me. And like part of the beauty of that is that, it's this stacking of human connection that has nothing to do with.
Which of course, the definition of that is I want to stack a bunch of human connections up. Then you can't do that if there's no humans in the stack, right? Like, of course, that by that definition. One of the things I really like, though, somebody, I forget who gave this example. It was someone was talking to a bunch of students, and they said, do you think it's possible to build a computer that's, roughly the size and shape, roughly the size of a human brain with all the capabilities of the brain. And the students, mostly said no. And then he said, well, what did you use to come up with that definition? Well, you used a computer that's roughly the size of the human brain with the capabilities of the human brain, right? So it's like there's a little bit of tautology in there of like, but like to your point though, it depends on the definition. Like I think you're right. Like you can't replace humans by something that's not human definitionally, right? Like if the part of the meaning and the emotion is about the human.
Well, and look, I think the single most important thing for people to get through their heads is like it is not necessarily a goal of the AI work. Certainly not the goal of the AI work that we're doing or that I'm doing is to replace humans. So you even look at something like GitHub Copilot. The reason that you build an AI that helps people turn natural language expressions of a thing that they want code to do into actual code is to help you, be able to get to the more important parts of your job more quickly.
We did get a very nasty letter early on in doing rightly from the Medieval Scribes Guild saying that we were replacing scribes by doing this newfangled word processor thing. I'm kidding. But of course, like nobody cared, right? Like we had long since replaced them and we understand that people need to write their own stuff and it's awesome. Right.
Yeah.
And it makes you better. Like the tool makes you better as a person, makes there lots of more value in the world, which is what's going to happen with these tools too, right?
It unlocks creativity. It does it does the thing that all of these tools eventually do. And like the trick is just sort of managing the transition, I think.
Right.
So we are at time. I could go on for.
I knew we would not get through all of our questions, man. Like
but so I do have one last question. So I ask everyone on the podcast at the end. Outside of their work, and most of the people we talk to, their work is a thing that they find fun. But like outside of the things that you get paid to do, like what do you enjoy doing in your free time?
I do lots of different stuff. I'm kind of a maker, as you know, as you are. Like, so I got really into fountain pens for a while and making fountain pens. I got really into old time music. I played bluegrass mandolin and Celtic mandolin and old time mandolin. So I go hang out with people. That's really been fun. I took a mandolin with me all over the world. This little travel mandolin. So I played bluegrass on a stage in Tokyo and played bluegrass with some folks in Sydney and played actual Irish music in Dublin. So that's super fun. I mean, it's just, it's all kind of connected to me. I like cooking. I like making stuff. I kind of like getting into the world and doing things. So I have too many hobbies, actually. Like I could answer that. I could spend an hour on that question.
I reject that assertion. I don't think that there's anything.
You and I have that in common.
Yeah, there's no such thing as too many hobbies.
But that's, you got me going on leather working recently. So that's kind of, got a pile of leather I look at guiltily every once in a while. Think I should do something with that. So.
Oh, you should totally do something with that. Cool. Well, thank you so much for taking the time to chat with us today. This has been a great conversation, and we're happy to have you on the show.
Yeah, super fun. Have been looking forward to it, so it's great.
All right, that was a super fascinating conversation with Sam Scalacci. So one of the really interesting things you two were talking about, you're getting into AI, and one of the things that was said was like that AI. What's so interesting about it is that it's not that it thinks like us, but that it doesn't. Could you expand a little bit more about that?
One of the things with AI is we're just seeing it more and more over the last handful of years as being an assistive tool, like a thing that helps us with the things that we're just not great at. And this has been sort of true with most of computing technology. CPUs are better than human beings at arithmetic. Like their computer algorithms are better at dealing with certain types of complexity than human brains are. And like this is certainly true with AI. There are things about human creativity and like intuition and all of these things that we actually take for granted that are very hard for AI systems to do. Whereas like there are all of these things to do with complexity that AI is getting increasingly good at doing. And so the thing that I think we ought to be doing over the coming years is like just sort of leaning more more into those differences than trying to, build things that are exactly like a human brain. Because like basically what
Right.
we want to do is build these tools that can help us offload all of the repetitive, irritating cognitive things that we're doing so we can go spend more time on the things that are uniquely human and special and rewarding and fulfilling.
Yeah, no, and you kind of you're mentioning like you wrote a journal article kind of to the same point, right?
Yeah. Yeah. I mean, so the journal article was in the American Academy of Arts and Sciences, did a special issue on AI and society. And my article was on a framework for thinking about AI as a tool for assisting us with cognitive work. The same way that steam engines and sort of mechanical devices in the 18th and 19th century were new ways to assist us with physical work for picking heavy things up, from moving heavy things from one place to another, for doing this sort of rigorous heavy mechanical work over and over and over and over again. It is essentially AI is a new type of steam engine, and we don't quite understand everything that it's doing yet, the same way that we were inventing these machines before we had the physics of thermodynamics.
Right.
We're slowly figuring out exactly what the science of cognitive work is, and how you measure it, and how you sort of see whether you're making progress towards making it better and better, and you're building the right machines to go do it. But that is, I think, the right framing for thinking about it. It's they're just tools. Like GitHub Copilot, for instance,
Yeah.
it's just a tool. Instead of having to go look up a whole bunch of stuff, you just sort of tell the machine what you're trying to accomplish,
Right.
and it writes some code for you.
Right. It's just a tool. I mean, that's why it's called a co-pilot. It's not, the pilot. It's not doing it for you. It's assisting you. You're exactly right. One kind of final thing I wanted to touch on. Sam kind of mentioned he feels like we're on the cusp of this big fourth kind of wave of
Yeah.
of advancement. Sounds like he can just taste where we're going to be. Are you on the same wavelength with that?
Oh yeah, very, very much. I am more excited about where we are and where we're likely to be over the next handful of years than at any point in my career as a programmer and computer scientist. And I'm 50 years old, so I've been doing this for almost I sound like my grandpa now. I've been doing this for almost 40 years now. I wrote my first program when I was 12. And yeah, so I've lived the three big revolutions that we've had. So you had this transition from computers being scarce,
Right.
to everybody has one. And I went from information being scarce to you have the internet, and
Right.
information is no longer scarce. And you went from computing being sort of physically tethered to being physically ubiquitous, your smartphone. And I think what we're about to have happen now with AI is another transformation, where the thing that's hard right now is technology is brittle. It is super challenging to use still. Things crash, user interfaces are complicated. One, you have to have 5 programs come together, or 5 apps to do the thing that you want to do. And I think very soon now we will have co-pilots for everything.
Yeah.
You will have AI that can just sort of listen to you and hear what it is that you're trying to accomplish, and then can do all of that management of complexity for you to get your thing done.
No, yeah. I mean, I think it's exciting. And I mean, I think, Sam had mentioned this too, when you think about just how quickly all of this has happened, and how much quickly, how much shorter distance there is kind of between these different waves. I think that's really exciting too. So I'm glad that we have
Super
people
exciting.
we have people like you and Sam who are thinking about these things and are leading teams and doing research and all this stuff, because that gets me excited, right? And I'm sure that gets a lot of members of our audience excited as well.
Yeah, it's a good time to be in tech.
All right. Well, that is all the time that we have for today. Huge thank you to Sam Scalacci for being with us today. If you have anything that you'd like to share with us, please email us anytime at behindthetech@microsoft.com. And you can follow Behind the Tech on your favorite podcast platform, or you can check out our full video episodes over on YouTube. Thanks for tuning in.
See you next time.